So the plan of the talk is a little bit about the background, about the context. Pat's slightly better at those kind of things than I am. So, as I said, bear with me. What exactly we're doing in this particular scenario, we're looking at an education reform. So, as a labor economist, I look at sort of policy reforms. That's what we're interested in. What is the effect of a policy on something, and how can we use that in a sort of experimental setting? The data, the results, and of course the so what, why does this matter? What are we doing in the first case? So, social mobility, this is essentially our dependent variable. We're looking at social mobility is very topical. Me and Pat have used it before in prior research, and there's sort of still some unanswered questions about that. Obviously, it's a Pat's bullet point. It's essential for a fair and open society. Your outcomes. It's the attainment of class income positions should hopefully in an open society depend on your ability, rather than perhaps who you were born into. Who your parents are or who your networks are. So ability and effort matters, and that's it. I mean, social mobility is a sort of political debate. It's been a political debate, and it's still a political debate, and we want to see if we can add something to that in relation to education. Now, there is actually some work done by economists and social scientists about sort of social mobility over time, and we have to be careful about our definition of social mobility. I'm being a little bit vague here. I do actually know somebody called Joe Blandon, who's an economist, who's done a bit of work on sort of intergenerational earnings and the transmission of that. In fact, I have another paper with her where we're also looking at earnings and education, and both for America, for the US, and for the UK, it's kind of been found that sort of early studies of social mobility found that this American dream, the idea of the American dream, you can do whatever you want as long as you're able. It's not really dependent on where you come from and who your parents are. It's possible. Newer studies, more revised studies, have actually argued that social mobility is not that great. It is not that easy to move through the social spectrum, to come from a poor background and to move yourself up into a sort of the upper classes. And that is basically a really condensed version of the sort of social mobility literature. It's obviously very big and very topical. There's a lot of stuff out there. I refer you all to the paper, which Pat will write at some point. So let's have a look. This is more my field, the role of education. And obviously education is a very important factor for determining many things. I just have to refer you back to the human capital theory, Becker, Mincer, etc. Education can be seen as investment. It makes us more productive. It's one of the most important drivers in earnings, but also, obviously, it's a key driver of social mobility. And the question really is, what is the causal effect of education on social mobility or earnings? We're not really looking at earnings, although I think I will do an earnings component to this for the economists, where I'm going to present this in the summer, because they like earnings. They always shoot me down social mobility. They want earnings. So anyway, what is the big problem with studies? What is the general problem? It's of course causal identification, endogeneity, the self-selection. We cannot observe ability. Ability is unobserved. If you take any random data set and you look at people's education, there will always be something unobservable. I'm very hardworking, I'm very able, I got lots of education. Somebody else is very low, has low motivation, or has a different drive in life, a different quest. They got low education. And if you're unable to control for this, sort of these classical regression-based techniques are just not going to help you out. This is sort of very old debate. And economists have generally tried to, let me see what's coming up in the next couple of slides. Okay, so I'll come back to the literature on education, return to education in a moment. There's something else, this partial equilibrium. Let me talk to you about that later at the end. This is what we call the Sattva assumption, or also individualistic treatment effects, depending if you believe in Rubin or Munsky. It's the same thing, they call it differently. I'll come back to that later at the end, I think, when we talk about the results. I just mentioned human capital, of course. Skills lead to more productive and attractive employees. There's a flip side of it, well, not the flip side, but there's another theory, sort of the theory of signaling. and credentialism. You know, it's not really your education which matters. It's a kind of, it's a piece of paper. I have a GCSE, I have an A level, I have a degree. This is what matters. It's a signal people pick up. I have to be very careful. And I will say right now, what we are picking up, what we are estimating, cannot differentiate between these two. This is if you can, you will surely get a Nobel Prize. It's been on the quest for a long time to try and differentiate between these two. There has been a recent study which focuses, particularly what we're looking at, is the 1972 education reform, which says it's about 50-50. Okay, you can kind of split the return. Well, maybe 40-60, something like this. They use some other similar identification method called using the Easter leaving rule. Don't want to go into that, but the mechanism could be human capital transmission or kind of signaling theory. Either way, the end effect will always be education will make you earn more, you're more socially mobile, etc. So, let's have a look at our identification strategy. Am I rushing through this too quickly? Sorry, I'm trying to get to the interesting bits, which interest me rather than to the. So this is what we're going to do. We're going to use the raising of the school leaving age, called ROSLA, which happened on the 1st of September in 1972, to help us identify the causal effect of additional education. Clearly, you know there's a current debate, a political debate, about raising the school leaving age to 17 in 2013 and to 18 in 2015. Okay, so imminently, coming up very soon in our society are these kind of policy events, possibly. I mean, this hasn't been 100% decided yet, but it's, we're well on our way of raising the school leaving age again. Now, that's quite a policy, forcing people to stay in school for an additional year. Okay, it's it's like conscription in Germany. You're forcing people to go to the army. That's quite a social intervention there. What are you doing? You really have to. It's very important to analyze what is the effect of this policy. How does that feed through into society? It's happened several times. Obviously, data. So this whole school leaving age happened at about in the sort of mid 1800s to late 1800s. These first couple of laws were implemented. The most commonly used reforms in the literature are the 1972 one, which raised the school leaving age from 15 to 16, which is a very important reform because from 15 to 16, of course, you're hitting the O levels. So you're starting to hit this credentialism idea. Okay, I have a piece of paper, I'm qualified. Before that, just after the Second World War, 1947 was the 14 to 15 schooling. It was raised from 14 to 15. That's also been used a lot in the literature, but we won't be focusing on that. So that's that really. And the interesting thing is, of course, that this was a nationwide strategy. It's a political reform. From one day to the next, you are forced to stay in school for an additional year. There's no regional variation, not by school, not by nothing. It's just that's the law and that's the way it goes. So that's a very powerful kind of discontinuity which occurred at a particular point in time, which will hopefully help us identify something. All right. And what we're going to be using is this regression discontinuity-based design. And this is this quasi-experimental technique, which has become very popular in the last 10 years in economics to evaluate programs. Unlike with RCT, there is no random assignment. You're not randomly assigning people to treatment and to controls, okay? But you're creating, shall we say, this kind of quasi-randomization by looking at people very close to the discontinuity. And that's what I want to show you here on the next slide. And this is it. This is the key to understanding what we're doing. You have an assignment variable, which you're going along the assignment variable. This can be anything. This could be test scores. This could be time, time 0, time 1, time 2, then program implementation at time 4, time 5, time 6, something like this. Our particular case is going to be age or, date of birth. It could be whatever. The important thing is that at a certain point of this assignment variable, people are assigned, the probability of assignment goes from 0 to 1. You get variations on the theme, but I will explain that later. And this discontinuity could lead to a jump in a particular outcome variable. The outcome variable could be whatever we're interested in. originally in this paper we were going to look at, I think we wanted to look at, people's opinions, about society. Are you against, what is your opinion of marriage? What is your opinion of sort of gay rights and all this kind of stuff? So I mean, you could literally have whatever you want here on the left hand as an outcome. Okay. The important thing here is that let's say everything else stays the same, nothing changes. At some point, there's a discontinuity here, right? And what you do is you compare essentially the outcome variable y here with the outcome variable when assignment takes place here, and your causal effect of whatever your let's say your program, your treatment is, will be that difference there, right? There we go. That is a kind of the graphical representation of a discontinuity framework. Okay. I will show you in a moment how this translates into practice, because there is a question about what you do with data on this side and data on this side. But theoretically, what we're looking at is a particular educational form. If I could have access to the entire data for the whole population, all I would have to do is compare the outcomes, let's say the earnings outcomes of people who were born on the 1st of September 1975, and compare that average to the average of the day before. That is the causal effect of an additional year of schooling. It's just, I mean, obviously at some point that's what RCTs are, right? You take an average, you take the difference, and you're done, you can go home. That would be the perfect scenarios. Obviously, in reality, there's all sorts of complications and problems. Some of this we'll talk about. Let me see what the next slide is. RD designs are invalid if individuals can manipulate the assignment variable. Well, in our case, they cannot manipulate the assignment variable. Your date of birth is not manipulatable. Okay, you are born on a particular day, and that's that. So the first criticism is not. It is sort of people who are looking at test scores. It becomes a bit more complicated because, of course, you can as a student, you can decide how much you want to study and perhaps what kind of test score you would like. Okay, for example, there's that if you look at degrees, 60% or more give you a 2-1, and 59% or less give you a 2-2. Okay, people of course have a choice and they can select themselves, perhaps close to the discontinuity on either side or on the other side. So you've got to be a bit careful there. Obviously, also you have to hope that there's only one program in effect. Yes.
So can't people choose to stay on in school? So in a sense.
Yes.
And in actual fact, there may be some sort of
now we're getting into right. Yeah. So what we're going into is a fuzzy regression. That's the last point. Sharp versus fuzzy.
Can I just something as well? You're talking about it being people's birthday, but normally in schools it's like if you're born before a certain day, you're in a certain year of school and things like that, isn't it? So
it's called this is that month of birth rule. I'll tell you about that in a second.
Sorry.
It's also a very favorite. I have another paper looking at month of birth, but I'm still writing that. Here we're looking at being born at a particular point in time, and whether you are forced to do an additional year of schooling. Okay. Let me go through the bullet points. Obviously, we're hoping that there's only one effect taking place. There's only one program looking, which changes the schooling on at that particular point. If there were two educational forms, you're going to have a problem, okay? But I can assure you that's the case. Graphical representations in this kind of framework is very important. You need to give people an idea of how the data looks and what kind of functions you're drawing through the data. So we'll have a look at that. There is an interesting debate, especially coming from the econometrics guys, about what kind of regression functions, here we go, are you going to draw through your data. Here you can see that that's a parametric slope. Parametric slope is a regression line. This is where the regression comes in. You can obviously put that into a multidimensional setting, and you can have additional variables controlling for that trend. You add in your dummy variable, you have a break, and that's your identification there, okay? We're actually going to go with a non-parametric framework. That's our preferred specification because it relaxes some of these functional form assumptions you see with this regression thing. The disadvantage of non-parametric estimation is that it's not very efficient. I mean, the ultimate non-parametric sort of estimation is just what I was talking about. You take the people one day before, one day after, and you just do a means test. That's kind of very non-parametric, obviously there's not really enough data, so you start taking people more and more further away from that discontinuity. But of course, the further you go, the more people change, right? People born in 1955 are completely different to people who are born in 1965, right? You have these generational effects, Generation Y, Generation X, etc., etc., etc. So you have to make a bit of a trade-off. It's very data dependent, this analysis, very data dependent. And so it's not efficient, it's very data dependent, and there is a big question about sharp versus fuzzy design. Do not really want to go into this, but because I'm still sort of contemplating what exactly our design is. But of course, in reality, what happens is that the assignment might look like this, but well, you'll see it in a moment that the assignment probability. So, if the assignment probability sort of gradually increase, and then there's a small jump here, and then they gradually sort of taper off like that, you might find that the probability of assignment is only 0.5 or something like that. It doesn't change from 0, 1. And if the change is less, you still have a random element, you still have a discontinuity, but you start ending up with this instrumental variable framework. So you're going into a different direction, which I will not talk about here today because it just means more results, more discussion, more complication. So at the moment, we're sticking with a sharp design, sharp non-parametric design. How am I doing for time? Am I okay?
Goodness, forgotten.
I'm sorry.
Bad chat, yeah. You're doing fine. Probably about another sort of 10
All right, good. So let's get to the results. Just to show you that obviously I'm not coming up with this out of the blue. There's a prior literature to this. This 1972 ROSLA reform is very well known, at least from where I come from, labor economics, education economics. There's some very nice papers. But what you can see here, what I thought was interesting, is that a lot of the previous studies actually used this as an IV instrument. And some of them still do, but there's a kind of there's a movement towards regression discontinue, redoing old results using RD-based approaches and seeing what comes out. And it's very interesting, actually. I can't go into this debate right now, but I know that previous studies for earnings, for example, has found general returns of 15%. An additional year of schooling gives you 15% return to earnings. And there's a kind of a revisionist literature emerging at the moment which suggests that the effect is only half. It's only about 5, 6, 7%. Partially because, and this is all on the same data, right? It's just regurgitating old data, but all because we're using these new identification methods. Let's see what comes out. Anyway, let me talk about the data very quickly. We're using, also, actually, one of the motivations behind this is because there's a new data set coming out, Understanding Society. The UK, it should be LHS, Large Household Survey, I think. I don't know why it's HLS. Anyway. Pat was, of course, one of the scientific advisors on that. That's why I knew about it. And it came out just before Christmas. Unfortunately, the data which was released is only the beta version. I'm still waiting for the full release. Once the full data has been released, I will jump on it greedily and analyze that. But to sort of supplement the results until we get access to the full data set, we took the Integrated Household Survey, which is also a very new one, also released in 2010-11. And of course the good old-fashioned British Household Survey. Let me just tell you, one of the things we're really interested in is we want to look at sort of stratification. We want to look at where people come from, in particular, sort of both the BHPS and the Understanding Society Survey contain information on parental background. Okay, because we think that the effect, the discontinuity, the jump in the discontinuity is much greater for people from poor socioeconomic backgrounds. Okay, and we want to stratify our results by that. You know, what happens to poor people if you make them go to school for an additional year? We think that question is very important. This is just a quick overview of the advantages and disadvantages. I will tell you right now what the advantages and disadvantages are, basically size, sample size. The BHPS has got 10,000 original sample members. We can pool all the data and get about 100,000 observations. The problem is the education that obviously doesn't vary, right? Like you're born in one, you know, your date of birth doesn't vary at all, so you know your standard errors will still reflect that you only have 10,000 individuals, which is not really enough. The UK HLS is better. It's got 400,000 people in its sample. Once you condition out all these people who are older and younger and who are working, you're left with 100,000. So that's good. 450,000, yeah, and 450,000. So that's very large. That's very good. And the UK, the next one which is coming out, this Understanding Society, will have 100,000 people. Okay, so that's very good. I'm hoping to get access to the ONSLS, which will get me into the millions. the reason why I'm quoting all these large numbers is because I want to do stuff non-parametrically. I want to look at very close to the discontinuity. I don't want to include all those people born in 1955 and 65 and 70. I don't want them in my results. So I really need lots and lots of numbers on those years, which are close to the 1957. All right, measuring social mobility. I'm going to skip over this because this is really just a question of how we define our dependent variable. Long story short, we're using a continuous measure of social mobility. There's a kind of transformation that, there's things like the goal. Because people have SOC codes. SOC codes don't really lend themselves towards a regression framework because, you can't really compare them. So you can do transformations of these SOC codes. You get your Goldthorpe scales and your Cambridge scales, and we're using something called the Kamsa scale, which is very similar to the Cambridge scale. And basically what it gives you a continuous distribution from 0 to 100 with a mean of 50 and a standard deviation of 15 of how you can measure what is the occupation of people. You can see here on the right-hand side, you will have things like doctors, academics, managers. On the left-hand side, you will have people like, what have we got there? Millers, furriers, car park attendants, etc., etc. Also, this depends on women and men have different scales because obviously, the social stratification for men and women is different. If I'm a man and I'm a doctor, it's a completely different thing. If I'm a woman and I'm a doctor, it means different things. So it's a bit complex. I don't want to go into that. But essentially, obviously, higher Kamsa scores are obviously related to things you would expect, like you make more money, you are more interested in politics, you have a better health, you're more satisfied with your job, etc., etc. That's really just everything I've just said earlier. Let's have a look. Here we go. Let's have a look. Let's have a look at some data. And the first thing you do in this kind of design is you can't go straight to the outcome variable. You have to look at the assignment variable. And you have to see, is there actually discontinuity? What are you looking at? Is there a jump? Is there a jump? So we're using different data sources. And what you can see on the left-hand side is, well, you see two things. The blue line is the probability of leaving school at 16. And the red line, it's a bit difficult to see, well, the red line is sort of the average years of schooling. You can see that the probability of leaving school after age 16 jumps quite significantly from about 0.7 to 0.9. It's sort of hidden behind that up there. So there's a significant jump in the probability of people staying on till after 16, which is what you would expect with a reform which forces everybody to stay in school till 16. There is a very interesting question about why it doesn't reach 1, and it took me quite a long time to figure out what it is, but I found the answer. I can tell you later what it is. What I was worried about is that the years of schooling certainly do not jump up by 1. I was expecting that the average years of schooling also jumps up by 1. You can see it jumps up nowhere near that much. And also there's a very interesting question why it doesn't go up that far. Nonetheless, there is a jump. You can see it's not significant here because of sample size in the BHPS. But let me show you all data sets before we draw a definite conclusion. You can also see here, if you look at qualifications obtained, the probability of obtaining a GCSE jumps significantly for those people who were born after 1957. That's a significant jump right there. Look at that. Okay. It does not jump for A levels or for degrees, which means that it's really a kind of, it doesn't filter through, it doesn't cascade through the education spectrum, right? It's just, you're forcing people to stay on to 16, you're forcing them to take GCSEs, they are more likely to obtain GCSEs. They're not more likely to get more A levels. Obviously, it falls down here because you're looking here at very young kids. This is also conditional on people actually being in the labor market, okay? Because we're interested in labor market outcomes. This is Understanding Society, which is that new data set. Again, you can see that jump in the probability of of staying on to school till after 16. That's fine. Years of schooling it's nearly significant, that jump here. It's still not very large. But again here you see the GCSE jump, no A-level, no degree jump. And finally, because I was a bit annoyed, I wanted to find the years of schooling jump. I took the IHS, I really boosted, I went with a massive sample size, and you can see that the confidence intervals on that are obviously not touching each other. So all these differences are significant. Probability of getting a GCSE is significantly different. Years of schooling is significantly different, even though it only jumps up by, let's say, half a year. half a year increase. So on average, people get half a year of extra schooling. Let me continue, and then I'll have a question. So here's the same thing again. You can see these are people born in 1956, and you're comparing them to people born in 1958, and you can just see very beautifully that that little jump is now transported right there. Okay, all these people who were 10 years of schooling now have 11 years of schooling. There's still some left, and again, I will tell you perhaps later why that is like that. But anyway, why did we do this graphical analysis? It's to prove to people, to convince people, look, there's a significant change in the education policy. It really filters through. People's education did significantly change at this particular point. So we can use it to identify something. At the very least, we can use it to identify what might be the future effect of changing the school leaving age from 17 to 18, which will be very similar to this, because you're forcing people into the A levels. This is personally what we're interested in. We can't quite say much about this right now because we're really waiting for the new data set to be released with these massive, with bigger sample sizes. But I'm personally really, what I want to see in my latest, here we go. These jumps are bigger than these jumps. Okay, if you're looking at by parental occupation, the higher socioeconomic group, the jump is much less for those in the lower socioeconomic group. And we are personally much more interested in this group. But that's going to be very data-driven, data-dependent, and unfortunately you're going to have to wait a couple of months, well, until after the summer, to really find out more about this. So at the moment we can only give you a flavor. But really we're very interested in sort of the first quintile there. It's the same for women. Funnily enough, you can see here that the education jump is much higher for women than for men. In general, across the board, women were more affected by this education reform. Anyway, so here we go. Regression-based results, This is where things get interesting. This is the naive analysis. This is the naive way of doing things. You're going through life and you're doing a regression analysis. You're not controlling for observables. In this case, results, the false conclusion would be, look, each additional year of schooling gives you approximately 2 points more on this CAMSA scale. Okay. So remember the CAMSA scale is average 50, standard deviation 15, between 0 and 100, so 2 points more can be quite significant, okay? But there's a suggestion here that education is strongly positively correlated with occupational standing. And let's see. Here we go. This is what I like. Okay, this is what I like. Now let's go to the RD framework and let's plot on the left-hand side the CAMSA scores for every single individual. You can see here's 0. Here's 0, here's 100. That's how sort of people's occupations are scattered, are distributed. And you can see here we have the date of birth, and that's our discontinuity right there. And the question is, what is that little jump there? You see, I zoomed in there, and you can see a little discontinuity there. I haven't drawn the confidence intervals on this because it will just mask everything. I just want to give you a flavor of how the analysis proceeds. And you can see the simplest thing you can do is you just draw a regression line from the left to the right up into the discontinuity, and then you draw another regression line from the discontinuity all the way to the end of your data set. You could stop here and say there's a very small negative impact. That's what you see here, right? Because the red line ends up higher than the green line. The green line is subject to the education reform. So here your interpretation will be education has a negative impact on sort of occupational outcomes. Clearly, what happens here is that these lines, this discontinuity is a function of these parametric fix, of these global, and this regression line is a global regression line. It's influenced by all these kids here on the right-hand side. They're dragging it down. And all these old people here who are sort of going towards retirement or whatever. So you have to be slightly more flexible in your regression specification. You might want to fit something quadratic like this. Okay? We do not want to be parametric. I don't care about these people born in the 40s and in the 70s and all this kind of stuff. We are going for something non-parametric here, like this. And you can see here there is a small jump apparently, but it's this alone is not quite enough to stand in front of you and say, look, I've identified a positive effect. What you need to do in this case is what you really need to do is it's called a I used it in another paper. I can't remember now. Sorry. Anyway, the idea is that you need to do this many times. Okay, you have to use very different bandwidths, different kernels, different non-parametric techniques, and have a look and see how that discontinuity changes as you apply sort of different non-parametric methods. And what you're kind of hoping for is that even as you start changing things, that change in the discontinuity should hopefully always be roughly similar. Okay? If you can find something like that, you have quite a robust argument that you're finding something. Okay, you're finding a causal effect, hopefully. So let's have a look at that, and that's what we do here essentially. You can see that we use varying data sets. Okay. The BHPS wave 1 refers to occupational outcomes in 1991. Wave 1 to 18 combines all the waves in the BHPS, and then the outcome for column 2 is, on average, over an 18-year period, is the occupational standing higher or lower because of this reform. US wave 1 refers to 2010, and the IHS 2000 also refers to 2010. Okay. What I've done is I started with a baseline of a 1-year bandwidth. I said, okay, well, basically all these numbers, all they do is they essentially compare the average outcomes of occupational status 1 year before the reform compared to 1 year after the reform. And then I've increased the bandwidth, and you see bandwidth 200 is 2 years, 3 years, 4 years, 5 years, until I get 5 years. Every time you increase the bandwidth, you can see your standard errors go down. Okay, so you have more, the sample size increases, you have more power to identify something. However, there's a real danger associated with looking at a 5-year bandwidth, because you might not be comparing people who are observably and unobservably the same. Okay, that's just what I said earlier. People born in the 70s are different to people born in the 50s. It's as simple as that. Unobservably, they will be different. The whole identification here is based, of course, on the fact that people are characteristically observably and unobservably similar right next to the discontinuity. So what we found here so far, I mean, you might be seeing all these numbers, there's nothing. We can't see anything. Okay, and that's, of course, yes, I'm nearly finished. That's, of course, exactly what you see there. It's a very small discontinuity. Once you take your standard errors into account, you just don't see anything anymore. Okay, so that was a bit, perhaps disheartening. The conclusion is, giving people an additional year of education doesn't improve their chances of getting a better job later on. However, looking at what we are interested in, this was always our initial idea, is to look at a biparental background. And once you look at biparental background, there is some evidence down here that it does favor, there is a significant positive effect for people from from kids who come from lower socioeconomic backgrounds. So the education reform had an effect for those who came from poorer parents. So we're quite happy with that. However, at the moment, because this is very data-driven, we really can't make a big deal about this. It's very preliminary, what I'm telling you here. We need to reconfirm this using better data sources. And in fact, this is why I'm talking with the ONS guys right now about getting access to the and they're making things very difficult. I mean, the paperwork you have to go through is unbelievable. These guys are so difficult with life. So that's our preliminary conclusion, that everything is we can't find evidence of a schooling impact on occupational-based social status. There are some interesting results for disadvantaged groups. We think this type of analysis can have very interesting implications for the proposed raising of the school leaving ages in the future. And the work which needs to be done is just what I talked about. I need to have a personal discussion with Pat about, do we go with a sharp or fuzzy design? Here we go. Cross-validate the bandwidth. That's a technical term for when you do things lots of times. Okay, I need to do that properly. We want to look at the ONSLS, and we want to wait for understanding society. So this is, there you go. We used a random event, essentially. You are born here or there. There's a policy being implemented, and we look at people just to the left, just to the right, and that's our identification. That's our randomization right there.